I'm Dr. J. Kaliga Rani, working in the Department of Mathematics, GTN Arts College, Dindikkal. So in this video, I'm going to teach in set. Okay, the topic is set, which is a topic in the course title Fundamental of Mathematics and the course code 20 UMA 11. Okay, so regarding this topic, what we are going to see, that is an overview. First, we are going to see what is a set, the definition, which mathematician found that, in which period, like that we are going to see in this set. Next, how we are going to describe, the description of the set. Okay, we are going to describe about the set. So, description. Okay, and the third one is the types of sets. The types of sets. The next title is subsets. Regarding the subsets, the first one is properties and the second one is the number of subsets. The number of subsets. Okay. The next one is equality. Equality of a set. Then finite or infinite set. Finite or infinite set. And the last one is the operations on the set. Okay. So first we should know what is a set. Okay. Before that, the set is created by the German mathematician George Cantor in the year 1845 to 1918. Okay. So he created this set theory and he discussed in this period. Okay. Suppose, what is the set? The definition of a set. The definition of a set is a collection of well-defined object. A collection of well-defined object. So, it should be well-defined. What is the meaning of well-defined? Suppose we are saying a person is intelligent. Then how can we say that it is well defined? Because according to me, the intelligence is different, and according to somebody, the intelligence will be different. Okay, so I can't say that a person is intelligent, a good book, like that we can, a good author or a good cinema, like that we can't say. Okay, it is not, we can say, but it is not well defined. It is not a set. Okay, so the definition of a set is a collection of well-defined objects. A collection of well-defined objects. Okay. Example, number of students studying in GTN Arts College. Number of students studying in GTN Arts College. Because so many colleges will be available in Dindikkal. In particularly we are saying that the number of students studying in GTN Arts College. Then we can say that it is a set. Okay. So commonly we can't say, we should be it should be well defined. Then we can say that it is a set. Okay. Suppose not a set. If I properly remember, my teacher would have thought that not a set is the number of person with no head. Number of person with no head. Number of person with no head. Okay. Like that they will be saying. So like that we can't say that it is a set. Okay. The second thing is, so we have defined what a set. How you describe the set is, we can describe in three different forms. One is roster form. One is roster form. The other name of roster form is tabular form. The next one is enumeration form. So, the other meaning of this roster is tabulation or enumeration. And the second one is set builder form. Set builder form. Okay. And the third one is precise statement. Precise statement. So first I should define what is a roster form. So roster form is nothing but listing the elements inside a bracket by separating it with the commas. Okay, listing all the elements inside a bracket by separating with the commas, which is known to be as this roster form. Okay, for example, A is equal to 1, 2, 3, 5 like that. Okay, this is roster form, or B is equal to some A, B, D like that. So here comes that how we are denoting this set. We are denoting the set with the capital letters A, B, C or S like that. We will be denoting the set with the capital letters and the elements will be written in the small letters. Okay. Suppose A is an element of this capital A is simply written as A belongs to this capital A. Okay. The meaning is A is a element in this capital A. Okay, and suppose it is not the element, we will be writing like this. So, A is a element of this capital A. Okay, then the next thing is set builder form. Set builder form is nothing but we will be writing it as X set of all. X is a positive number less than 5. Less than 5. The thing is, in this set builder form, it will be possessing a common property. What is the property here? It should be a positive number and it should be less than 5. Like that, we say that it is a set builder form. Suppose you take in the roster form, no need to have a common property, no need to possess a common property. Okay, and the third one is the precise statement, that is simply we are writing a statement. X, where X is a even positive integer. X is an even positive integer. Okay, like that simply we can give it as a statement. Then we say that it is nothing but a precise statement. Okay, so three different forms we can describe the set. One is the roster form, second one is set builder form, and the third one is nothing but the precise statement. Okay, so the next thing we are going to see is the types of set. The next thing is types of set. So in this one we are going to see two different types of set. Two different types of set. The one is empty set. The one is empty set, and the second one is empty set, and the second one is singleton set. Empty set and singleton set. What is the meaning of empty? So empty means no elements will be there in a set. Even then we are saying it is a set. Okay, no elements will be there in a set. That is empty. Okay, how will you denote it? We can denote it with like this, or simply like this, or pi. This is known to be as empty set. The meaning is no elements will be there in the set. Okay. So here singleton set. So the definition is itself in this name itself. Okay. Singleton set means only one element will be there in the set. Only one element. So A is equal to 2. A is equal to 2. Only one element will be there in a set. Then we can say that it is a singleton set. So two different types, one is empty set and another one is singleton set. Okay. The next topic is subset. What is the meaning of subset? Okay, we are having a whole set and we are having another set which will be a smaller set, and all the elements in the smaller set will be there in the superset also. So the big set, I am saying it as superset, and the smaller set we can say it as a subset. Okay, how will you denote it? We will be denoting like this. This is a symbol for subset. What is the symbol? Is like this. This is the symbol. Okay, so A is a smaller set, S is the superset. We can say that A is a subset of S. That is, every element in A is also an element of S. Every element in A is also an element in S. Okay, so here we can say that this A is included in S. A is included in S, or we can say like this, S is a superset, so S contains A. S contains A. Can you understand? Here S is the superset, A is the subset. So S contains A. The very good example is X set of all X is a GTN student. Okay? And A is X set of all X is a first year BSc physics student. So which one is the superset and which one is the subset? By seeing itself we can come to a conclusion that S is the superset. Why? Because it generally denotes GTN students. So if you take it as a GTN students, I think so that is 23 departments will be there. So many departments are there, everyone is a GTN student. That is the superset. And if I take A, X is a first year BSc physics student, he is one of the department and first year. Okay, then it is a subset. So every student in first year BSc physics is also a student of GTN. Therefore, A is a subset of S. Okay, so easily we can understand. The next thing we are going to see is the properties. The properties of the set. The first property is the empty set. The empty set is a subset of every set. If you take a empty set, definitely it will be a subset of the set. Okay, every set, any set it will be. Every set is a subset of itself. Every set is a subset of itself. For example, A is a subset of A. A is a subset of A, and the third one is A is a subset of B, B is a subset of C, which implies A is a subset of C. That is, regarding this A and B, B is a superset, the B is a subset of C, therefore A is also a subset of C. Can you understand? These are the three properties. The properties are empty set is a subset of every set is a subset of itself, and the third property is A is a subset of B, B is a subset of C, then A is a subset of C. Okay. The next one is number of subsets. The number of subset for a set. We should say that the number of subsets. Okay, how many number of subsets will be there for a set? How many number of subsets will be there? The question comes. Okay, so we should define what is the number of subsets. If there are n elements in a set, then 2 power n subsets will be there. 2 power n subsets will be there. Okay, so suppose one element is there, then 2 power 1, so 2 subsets will be there. That is, suppose A is equal to A, then the subsets are, what will be the subsets? The subsets are first A itself, then the empty set. So here number is 2. Suppose I am taking A comma B, 2 elements, then what are the subsets is the whole set, then the empty set, then single set. So it is 2 to the power 2. So how many subsets will be there? 2 power 2, so 4 subsets will be there. In that the whole set is 1, the empty set is 1 and the remaining. Suppose I am taking 3 elements, how many subsets will be there? 2 power 3. So 8 subsets will be there. Okay. So this is regarding this number of subsets. The next one is equality. Equality of a set. So when we say that 2 sets are equal, when we say that 2 sets are equal, when will you say if all the elements of A is also an elements of B, then we can say that it is a equal sets. That is, all the elements in one set should be the elements in another set. Then we can say that both the set are equal. For example, A is equal to 1, 2, 3 and B is equal to 3, 2, 1. Whether these two sets are equal, the question comes. Here it is 1, 2, 3 and here it is 3, 2, 1. Whether it is equal? Yeah, obviously it is equal because here we are having 1, 2, 3. Similarly, here also we are having 1, 2, 3. Simply interchanging. Okay. So, 1, 2, 3 is available in B also. Therefore, the set A is also equal to B. For example, A equal to 1, 2, 5 and B is equal to some A, B, D. Whether these two sets are equal? No, it is not equal. Why? Here one is an element of A, but one is not an element in B. One is not an element in B. So, equality means whatever elements which is available in A should be available in B also. Then we can say that both the sets are equal. Okay. The next one is finite set. How can you define a finite set? So, the number of elements in a set can view and say that it is finite set. For example, A is equal to 1, 2, 3. So, this one we can say that the set is a finite set. That is, the number of elements in a set, easily we can say that, count and say how many number of elements are there? 1, 2, 3. So, it is a finite set. Okay. So, if finite set is there, then the next one is infinite set. What is the meaning of infinite set? Which is nothing but the opposite of this finite set. Okay. Finite set, simply you can count and tell. Infinite means which is not finite. A set which is not finite is said to be as infinite set. Okay. Infinite set. The next topic here is the operations, what we are going to see, what we are going to operate on the set. Okay, the operations. The first operation in the set is union. What is the meaning of union? So, union itself is simply combining the two sets. Union, the actual meaning is, suppose you are taking two sets, some elements are in A, some elements are in B, then union means the elements which are in A as well as the elements which are in B are both. Okay. So, the elements in A or elements in B are both, and we denote it as this symbol. Okay. Suppose A union B, like this we write, the symbol is U, like this U. So, A union B. So, what is the meaning of union is the elements which is available in one set or the elements which is available in the another set are both. So, I am saying it is or, you should note that. Okay. The elements which is in A or in B or in both. Okay. The second one is intersection. Intersection. So, what is the meaning of intersection is intersect, like that we are saying no, intersect. What is the actual meaning? The element which is in A as well as in B, the element which is in one set should be in another set also. Then we say that the intersection numbers we can easily count, and it is denoted like this, A intersection B. That is, it should be available in A as well as in B. Okay. This is A intersection B, and the third one is nothing but complement. What is the meaning of complement is, suppose I take a superset and I am taking a set A, the elements which are in the set S is the superset and the element which are in A is available. I have to find what is A complement means, the element which are not in A but in S. The element which are not in A but in S, in the superset. That is the meaning. Superset or in some other book they follow the universal set. In this universal set. In universal set, the element which is not in A is the complement. For example, B complement means the element which are in B but not in the universal set. Okay, the elements which is not in B will be taken as B complement. So, these are the operations we can see, that is first operation is union, the second operation is intersection, and the third operation is nothing but the complement. Okay. So, in this video, what are the things we have seen is, what the student can understand from this video is, first they can define what is a set. So, what is a set is a collection of well defined objects, and they can describe the set. How will you describe the set? Using the roster form, set builder form, and precise statement. Okay. And we saw what are the types of the set. So, the types of the sets are nothing but the singleton set and empty set. And the next topic we have seen is subsets. So, subset we saw two topics, one is properties and another one is number of subsets. Okay. And we also learn about the equality, the finite or infinite set, and some 3 operations we have learned in this video. Thank you.